India's achievements in science and technology has been increasing over the days. It is not something new. From ancient period, India has been known for its expertise in science, mathematics, astrology, and the good part is that we are continuing with that legacy. One such discussion is what I have brought before you today. Hello everyone, I welcome you to another video by Legacy IAS, where we are going to talk about the SARAS-3 radio telescope, a telescope which has the potential of really trying understanding our roots, our past, and hopefully if we know history, we'll be able to make history, and that is all that is being compiled in this particular video before you. Now, as far as this understanding this particular telescope, what exactly is making news? So this particular SARAS is a niche, high risk, high gain experimental effort, which means a lot of stakes are involved, but of course what comes out of it is also equally beautiful. It is an effort to design, build as well as deploy in India a precision. This telescope will have much greater potential in terms of the accuracy with which it will try to get us the objectives. That is something which speaks of the novelty of this particular telescope. The CMB distortion laboratory at RRI, basically this particular laboratory is the one that has pioneered the development of the state-of-the-art radio telescopes. The objective is to detect signals of high wavelength as well as low frequency. So two specific, very specific areas we're trying to target here, one of high wavelength and the other of low frequency. Now first let's understand a little bit about what these radio telescopes are all about. So these optical telescopes are the ones which collect a lot of this visible light and brings them into focus. It tries to, once it brings them into focus, it then further amplifies it. So when it's amplified, it is made much more easily available for it to be analyzed properly by various other instruments. So in terms of the exact collection, focus and as well as amplifying, and these telescopes are the ones which collect the weak radio light waves, which are basically refer to it by its frequency. They bring it to its focus and then they use it for amplifying. Alright, so optical telescopes as well as radio telescopes are the ones who perform these very similar objectives. Now radio telescopes are the ones which are used to study naturally. Alright, the radio light which is coming from where? Particularly the stars, the galaxies as well as the black holes, but other astronomical objects as well. So we're just trying to study the lights which is particularly coming from these three sources. Okay. Now this particular SARAS-3 radio telescope is indigenously designed in India at the Raman Research Institute. Alright. Along with, so it's a collaborative effort where we have other stakeholders as well. The Commonwealth Scientific and Industrial Research Organization, or the CSIRO, which is present in Australia. So we are all aware that these Commonwealth nations are the nations which comprise of the former the nations which had been colonized by Great Britain, and they now have kind of a similarity in terms of the lineage that they come from, a large influence of English. So there's a certain commonality that is there, and that particular Commonwealth is the one present in Australia, also collaborating with it. In fact, India-Australia relations, if we actually kind of look it up over the years, the way it has developed, especially because of strategic reasons in the Indo-Pacific region, it really speaks a lot about how further we can grow in our relationship. And with collaborators at the University of Cambridge and the University of Tel Aviv. Here we really have a very important contribution in India's relations, in India's foreign policy. The contributions of Israel in intelligence is also something which has been growing the entire time, all these years. That is also something which has contributed to the development of this particular telescope. Also, this particular telescope was deployed over the lake Dadinagala and also the Shravati backwaters in Karnataka. Alright, so this journey began back in 2020. Now, this particular news article is what came out talking about this Karnataka waters, whereby you see this particular telescope floating in the Karnataka waters trying to capture the early stars as well as galaxy. So the objective of this particular telescope is to, of course, design, build as well as deploy a very precise radio telescope in order to be able to detect this very faint radio signals coming from our depths of time, from our cosmic dawn, right? This is the place where basically our first stars and galaxies were formed in the early universe. So we're really trying to trace the genesis of this entire formation. You know, the whole much talked about the Big Bang theory and several other theories actually, which have kind of contributed to our understanding of present day solar system. Our continuous expeditions to finding friends of Earth in planets like Mars, determining that Pluto is no longer qualified to be a planet like other planets. So these kind of developments are such whereby we're just in a constant search to find out both our roots, understand our present and work towards the future. This particular telescope basically can provide us with information about the origin of the universe's first stars as well as the first galaxies. That is really going to be instrumental in trying to understand a lot of our current processes and be prepared for our future. Now, why is there a need for this telescope? So it is basically going to study the properties of the very early galaxies, the process involved by observing the radiation from the hydrogen atoms in and around these galaxies. Alright, a particular hydrogen product which is actually found in abundance in these areas, which are emitted at a frequency of approximately 1420 MHz. So megahertz is what we are basically looking at this particular telescope. The radiation is stretched by the expansion of this particular universe. Of course, we are, there have been reports and theories which some say that we are still more expanding and there are much more other galaxies to be found. So this particular radiation travels to us across space and time, alright, and arrives at Earth in a much lower frequency radio, and that is how it is being used by the FM stations and also the TV transmissions. This particular cosmic signal is relatively much more faint, alright, which is buried in the magnitude, which is much brighter radiation from our galaxy and the man-made terrestrial interference. So, based on this particular radiations which is coming from our galaxies and these terrestrial interference, basically we are trying to detect this signal, okay, using the most powerful radio telescopes. We have still not been able to achieve that particular point. So we are just trying to kind of enhance our capabilities by trying to just capture this particular extremely faint light that is coming from these particular galaxies so that we get back to the origins. Now, this particular telescope has actually achieved a lot in its journey. So it will help provide astronomers clue to the nature of universe's first stars as well as galaxies. The first of the time we've been able to reach the required sensitivity and also cross-verify the claims of the signal detection, the place from where we can basically capture them. It has also improved our understanding of astrophysics of the cosmic dawn. Alright, so through which we've basically understood that less than 3% of the gaseous matter within the earliest galaxies have been now converted into stars. So initial information is what is being provided to us. The earliest galaxies that were bright as far as radio transmission was strong in the X-rays, which heated the cosmic gas in and around the early galaxies. Now, according to this particular institute, RRI, which is coming with the first of its kind work, it has basically used data from an Indian telescope, and the scientists have determined properties of the radioluminous galaxies formed 200 million years after the Big Bang, and this particular period is what we understand as this cosmic dawn period. So the first time we're actually going to this particular space and doing it with much more precision than we earlier did. So here what they are trying to do, as I was telling you, use the hydrogen atoms and try to understand it, which is found in and around these galaxies. So this particular technology and methodology is something that is also very, very novel in its journey. We have been able to achieve new heights in this direction because we have the former director of RRI giving very important statements like the results from the SARAS-3 telescope are the first time that radio observations of the average 21 centimeter line have been able to provide an insight into the properties of the earliest radio galaxies that are usually powered by supermassive black holes. He goes on to say that this work takes forward the results of SARAS-2, alright, which was to inform the properties of the earliest star as well as galaxies. So it's a series of projects which is going on, and with every new such telescope that we're coming up with, we're really strengthening our own capabilities. So SARAS-3 has improved our understanding of astrophysics. This particular technology, this particular invention is something that we are really crediting this collaborative effort which has happened, and hopefully will be able to help us in future in trying to understand our journey in understanding these galaxies and our future ahead. I hope you find this journey of unraveling equally exciting. So to continue this journey, I need you to subscribe to Legacy IAS videos. Let me know if you've liked the magnificent efforts which India as well as other countries have made in this journey by liking this particular video, and share it with those who are still not aware about our past. Thank you so much.